Okay, so in this problem, what we're going to be solving is basically you've got, let's say, a field of some type, and you have a person who's standing here, and he's going to throw a ball straight up into the air. And the ball's going to go up, 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 up. The question that we'd like to figure out is, with what velocity, initial velocity, does the person have to throw the ball up in order for the ball to reach a maximum height of 100 meters? So, in order to do this, let's figure out what we're given. Obviously, we're given the 100 meters, and that, we're going to say, is delta D, 100 meters. But we have some other things which are implied, and it's important to recognize those. First of all, we know that our acceleration is negative 9.8 meters per second squared, and that's the acceleration due to gravity. In addition to that, we also have one other kind of sneaky piece of information, and that is the velocity at the top, the final velocity, and that is 0, because at the top it momentarily stops before it changes direction. So we'll say the final velocity is 0. Now, if you take a look at this, we have delta D, we have A, we have V final, and we're looking for VI. Well, it's not rocket science to figure out that this equation would probably come in pretty handy. V final squared equals V initial squared plus 2A delta D. However, we're solving for VI. So solving for VI, let's rearrange that equation and solve for VI. It would be VI is equal to VF squared minus 2A delta D. Take the square root. And now if we plug in our values, move the sheet up a bit, and we'll go V final is 0 squared minus 2 times, well, we don't have to put brackets around the 2, but I did already, 9.8 meters per second squared multiplied by 100 meters. And that's going to give us, get out our trusty calculator, to enter, notice the negative signs cancel each other out, to enter 9.8 times 100 times, and let's take the square root, and the answer is 44.3 meters per second. Now, how fast is that in kilometers per hour? Well, listen, kilometers per hour is the bigger number, so we have to multiply by 3.6. So if you go 44.3 times 3.6, 3.6 times, and you're going to get about 159.4 kilometers per hour. So almost 160 kilometers per hour, which, by the way, just happens to be really close to 100 miles per hour because of the 1.6 factor. So pretty much if you want something to go straight up into the air for 100 meters, that's how fast you're going to have to throw it straight up. And of course, this is assuming no air friction. Well, hope you enjoyed that. See you next time, boys and girls.